After publishing my talking about spin video, I got a question asking how two different spin axes can have the same tilt and efficiency. So in this video, I'll quickly go over it theoretically and give an example illustrating it. Let's go. So, as I established in my video, gyro degree is how far from perfectly efficient the spin is. But a key concept is that the maximum it can be is 90 degrees. Because if it keeps going, it just becomes less than 90 degrees from the other side. So in this case, imagine the ball is spinning from top to bottom. Now, aligned with the velocity vector, that's just backspin. And as you keep increasing the gyro degree, that spin is becoming less and less efficient until, right here, it's just slider-like. But if you keep going a bit further, now it's still slider-like, but it actually has a minute amount of topspin. Now look at the spin efficiency down here. Like I said, spin efficiency is the cosine of the gyro degree. As it approaches zero, as the gyro degree approaches zero, that spin is becoming more efficient. When it hits zero, it's perfectly efficient, is 100% efficient. But something to note is that it can keep going, and now the gyro degree is negative. Like I said, this would be a righty overpronating. But the degree of inefficiency is the exact same as the 5 degrees. So from the spin efficiency perspective, it sees -5 gyro degrees and 5 gyro degrees as the exact same when they would actually have different effects. So as an example, let's look at two different pitches that both have tilts of 12 o'clock and spin efficiencies of 0.707. So over this shoulder, I have one that has a gyro degree of +45. So basically, it's just a righty cutter. And over this shoulder, I have one that has a gyro degree of -45. So kind of like a lefty cutter. Now when you think about it, both have the same amount, not the same sign, but the same amount of gyro spin. They both have no side spin, and they have the exact same amount of backspin. So in that way, at the very beginning of the flight, they'll move the exact same way. But as their velocity vector starts going down and their gyro spin converts to side spin, the fact that the gyro spins have different signs will show in the movement. So this one, kind of like cutters and sliders do, will go, if it's moving towards the camera, this way. And this one will do the exact opposite. It'll go that way. So they'll move equally and opposite. Because their gyro spin had different signs, they convert to different signs of side spin. So basically what it comes down to is the fact that spin efficiency is the cosine of the gyro degree. It doesn't matter whether the gyro degree is positive or negative, because the cosine is taking the absolute value of that and converting it to a positive spin efficiency. And that's perfectly fine when you're looking at a single moment of movement, because like I said, those two different axes would have the exact same initial movement. What does matter is as that gyro spin starts getting converted to side spin, to know the difference of what it's going to do. Well, hopefully I clarified, and I'm always happy to take questions. Have a nice day.